So we have 8.1 notes, which is arithmetic sequences as functions. So we have a lot of vocabulary to go through in this topic. We have what a sequence is. It's a list of numbers in a particular order. We have what a term is. Each number in a sequence or series. We have a finite sequence versus an infinite sequence. Finite has an end. Infinite does not. It just goes infinitely. And then we have an arithmetic sequence, which is what we're going to be addressing today. So an arithmetic sequence is defined by being an arithmetic sequence when it has something called a common difference. That means it goes up or down by the same increment number each time. Okay? So in this particular case, so the one that we're looking at in this picture here on the side, we're going up by 3 each time, which defines, since we're going up by 3 each time, 3 is our common difference. Okay? So 3 being our common difference, that was what we call an arithmetic sequence. So the common difference is the difference between the successive numbers in an arithmetic sequence. So if your d is negative, that means you're going to be going down each time, and if your d is positive, you're going to be going up each time. So any of these vocabulary terms, in addition to any on 8.2, could definitely come up on your quiz, just to give you a heads up. So let's talk about the terminology and the notation that we use before we get into any of these, because it is a little bit different than what you're used to with x's and y's. So we use something called subscripts on these. You probably see these in chemistry, subscripts versus superscripts. So a subscript is like this. So a sub 1 means the first term. A sub 2 means the second term. A sub 3 means the third, and so on. A sub n means, a sub n is like more of like an open-ended. It's like a term. The nth term just means some term in the future. Okay, and n can be represented by any number, the term that we want to find. A sub n minus 1, it's to talk about the term before the nth term. A sub n plus 1 is the term after the nth term. Okay. Now, we can also identify a domain and range for each of these. Domain is always going to represent what position you're in. So if you're in a sequence, it's the first term, your domain value is 1. Okay. Second term, 2. So basically how many terms you have are going to be how many domain values you have. And then the range is always going to be whatever the actual sequence is. Alright, so let's go ahead and look at some examples. So first thing we're just going to look at is some basic arithmetic sequences, or if they are arithmetic sequences, we're going to determine that. So the very first one, are we going up by a common pattern each time, a common value?
Yes.
We're going up by what?
3.
Yeah, plus 3. So that means this is arithmetic, because it's the same thing each time. And that means our common difference is 3. So since we're going up, it's a positive common difference. If we were going down, it would be negative. Alright, and what about the next one? What do we go up from 1 to 4? And then this one? So we got a problem. Is this arithmetic? No. So we cannot find a common difference if it's not arithmetic. Okay? That's part of the rule. So any questions about that? Alright. So it says graph an arithmetic sequence. So first thing we're going to do is we have to find some of these missing terms in this arithmetic sequence before we can go about graphing it or anything like that. So first thing is, what would be the common difference here?
Negative 2.
-2, because each time we're going down by 2. So that then allows us to fill in the missing blanks. So what would be 6 minus 2? And then, good. So let's go ahead and plot these. So you might be wondering, well, I don't have an x. So this right here, this axis, represents the term that you're on. Okay? First term, second term, third term. So what would be the first term here? 10. So at 1, we're at 10. And at 2, we're at 8. And then the third term is 6. The fourth term is 4. The fifth term is 2. And the sixth term is 0. Now we can't keep going because our graph doesn't particularly go into the negatives, right? But that's okay. So that's what we have thus far. You can connect this. Now, what do you notice we're missing that most linear functions have? The arrows. That's true. It is finite. But something else. We usually graph in the form y equals mx plus b. You have your m, which is basically your d, your slope, yep. D kind of represents the slope, as you can see, right? But we're missing something else that we use very often, the y-intercept. So let's talk a little bit about that in context, because sometimes they give you problems that can throw you off a little bit about where to start. So notice that we don't have a y-intercept, because y-intercept would represent the term a sub 0, which would mean the term before the first term, okay? So it would be the term prior to the first term, what you could do to get from, you know, just to get you kind of started, right? So what would be our a sub 0? 12. So a sub 0 is something that exists more as a concept than actually exists, but it helps us to find what our starting point should be, okay? So you have to read the problem carefully, because sometimes the term they're giving you is a sub 0 to start, and sometimes they're giving you a sub 1. So you got to read really carefully the context of the problem. Sure.
What's the difference between a sub 0 and a sub 1?
So a sub 0, let's think about it this way. The very first, I don't know, paycheck you get, that's a sub 1. That's the very first term. Let's say your paycheck, I think we're going to do one similar to this, but your paycheck's going to go up $2 every month. Okay? So you start on month 1, you start with 9. Then it goes up to 11. So a sub 0 would be like what you started with before you got the raise, essentially. If that makes any sense. It's kind of like the before the first term. It's kind of tricky to think about, but it's more of a conceptual thing than like an actual thing. So our domain is going to encompass all the terms that we're referring to, okay? So we have the first term included, we have the second term, third, fourth, fifth, sixth. So we have 1, 2, 3, 4, 5, 6, 7. So we're talking about 7 terms. First, second, third, fourth, fifth, sixth, and 7. Our range is going to be what those terms actually are. Okay. So the main idea for us to do this is to show you that arithmetic sequences, though different than linear equations, can be represented and modeled by linear equations. Does that make sense? Okay, cool. So let's talk about the types of formulas you're going to see. Yes?
Is a sub 0, do you count that as your name?
No, you do not. It's a concept, not actually part of your sequence. So we have the arithmetic recursive definition. So recursive means something is reoccurring, okay? Recursive formula is only useful for one thing, really. It only allows you to find the term directly after the term that you already have. So let's say you want to find the 6th term, okay? You can find the 6th term by taking the 5th term and adding your common difference to it, okay? Say you want to find the 7th term. You can find the 7th term by taking the 6th term and adding the common difference to it. What's up?
I was curious if you write me pads. Because my teacher, listen, we've been late all year. I knock on the door, he opens it, and he goes, nope, go get a pads.
Why were you even late?
Because I go on the other side of campus there.
Well, that is a stupid decision.
I know, right? I appreciate
Go
that.
fill it out, though.
Okay. Have a good one, brother. Thank you.
Recursive formula tells how any term in the sequence relates to the preceding term. So basically the main idea here is that you take the term before and add d to it, okay? And the reason it's plus or minus is because technically when you add a negative, it's the same thing as subtraction. So an arithmetic explicit definition. So the main thing you need to know is explicit is way more useful, because explicit can help you find any term in a sequence if you have the formula, okay? Help you find any term in a sequence if you have that particular formula. So oftentimes you're going to have to come up with that formula on your own, okay? So the idea is if you have the first term and the common difference, you can find the 1,000th term, which of course you could do by continually adding the common difference, but nobody's got time to add 1,000 times. So this formula, you will often see it written like this. Where this is the first term. This is any term that you want, okay? But whatever term you plug in here, say you plug in the fourth term. When you plug in n, you got to put in n before, okay? So it has to match. Those two things have to match. And then d, of course, is the common difference, okay? So that's what all of those things mean, if you're wondering. And we're going to do some application problems with these as well. All right. So first question we're going to look at, we have the formula laid out. Now, I personally like to put the d in front of the n minus 1, but it's really the same thing. So, you know, same exact thing, it's just multiplication. So it says here, what is the 100th term of the arithmetic sequence that begins? So they give me 6, and then they give me 11. So right off the bat, I can find the common difference, right? What would be my common difference here? 5. It's going up by 5 every time. So if I have d, the only other two things I need to write, well, for the recursive definition, we're actually ready to go. The recursive is always a sub n is equal to a sub n minus 1 plus whatever d is. That's the recursive definition. So that just means if I have the fourth term, I can use this formula to find the fifth term. It seems kind of silly because you're like, I'll just add 5 to it, but you'll see when it's used in context. And then to get the explicit definition, I need to know d and a1. So what would be a1 for this one? Good. So the formula for explicit is a sub n is equal to whatever the first term is plus your common difference times n minus 1. And if you're wondering why the formula is n minus 1, it's because you never actually start at 0, you always start at 1. So that's the reasoning behind why the formula is that way. So sometimes you're going to see something a little bit more tricky. There's a few different ways you can do this. Like there's like 100 different ways I can think of, but I'm not going to try to overwhelm you with all of them. So let's talk about it. Do we have sufficient information to find the common difference here? No, unfortunately we don't. So here's the problem, or here's what we got to do. Essentially, we have to find these missing terms. So let's talk about it a few different ways. What term is this? A1. What term is this? A4, right? Everybody see why that is? Okay. But we want to find the missing terms in the middle. Now, we know that any particular term in an arithmetic sequence represents a coordinate, like we talked about on the last slide, right here. So, what would be the x coordinate that corresponds with the 100? 1. I did that twice today with the 100, I messed it up, I don't know how. So 1 comma 100, and then what would be the coordinate that corresponds to this one?
4, 82.
Good. So we know that common difference is essentially slope of the line, right? So can we find the slope of this line using these 2 points?
Mm-hmm.
Yeah, do you guys remember how to do that? Y minus y1, x minus x1. So that gives you negative 18 over 3, which is negative 6. So that's our common difference. So we're going to say d equals negative 6. That's just using slope formula from algebra. Now there is a little bit of a trick that you can do to get this that I can show you guys. But I just don't want you to like get too wrapped up in it. This is how I do it like on a whim. So here's the trick. You can also, if you like the trick better, the last term given minus the first term given. Okay? So last minus first. Okay? Over number of spaces plus 1. So last minus first would be 82 minus 100 over, how many spaces are there? Plus 1 is, so it would be negative 18 over 3, which would be negative 6. So that's like a little bit of a trick you can use, but whatever method you prefer works. Okay? Alright, so now that we have our D, we can find the missing ones, right? So what would be term 2?
94.
94. And what would be term 3? 88. Thank you. Sorry, I was just like a little frozen there. Okay. So here's the recursive definition. It's a sub n is equal to a sub n minus 1 minus 6. And explicit is a sub n equals, it's your first term minus or plus your common difference times n minus 1. And that's how you set up those two formulas every single time for arithmetic. So any questions about that? Alright, cool. So find a term in context of money. So it said Geraldo's employees offers him a pay rate of $9 per hour with a 15-cent raise every 3 months. How much will Geraldo earn per hour after 3 years? So this question is a little bit tricky. So let's think about it in context. The first term would represent his money after his first raise. Okay? So if he started with $9, how much is he going to make after his first raise? $9.15. So you see how we had to put in the work to find the first term? So what could $9 represent? Income. A sub 0. So that's where a sub 0, you see how it comes into context here in this particular problem? Why we have to use the concept of a sub 0 to help us find a sub 1. So our first term is actually 9. I don't know why I put it like time with 2 dots. My brain's a little off today, I think. I don't know what's going on. There we go. That's better. So we know our first term. Now we need to determine all the other stuff. We know that our common difference is every time it's going to go up by 15 cents. Now here's where it's tricky, n. If you get a raise every 3 months, how many raises are you getting in 1 calendar year? 4. And then if it's happening for 3 years, how many total raises is that? 12. So everybody see how we got 12? Okay. So now that we have all of this, we now have sufficient information to write an explicit formula. Once you can get an explicit formula, you basically everything's pretty much coming together at that point. So just to remind you, this is the general formula for the explicit. And if you have enough stuff to put in here that you can get one of these, it's really useful. So this would be our general explicit formula for our situation. First term plus the common difference times n minus 1. And then what am I going to be plugging in for n? 12. So to find the 12th term, I do 915 plus 15.15 times n minus 1. So you can type this all into the calculator as is. I believe it will work. If not, you can do it in 2 parts.
Does 1 mean the same as the last lesson we were taking on?
What?
Does n mean the same as the last lesson we were working on?
Which one had n in it?
What does n mean?
It's any number that you want to obtain. Like you want to know the term that you want. So that's going to be $10.80. So after 3 years, he's going to make $10.80. That's kind of lame. That's not a huge raise, but you know. Anyways, so for the next question, there is something called the arithmetic mean that we'll talk a little bit about. So you probably remember this from geometry. Anybody remember arithmetic mean? Or geometric mean we talked about in geometry. But this is basically just a fancy way of saying if you have 2 terms and you want to know the middle term, you can basically just average the 2 terms together. Okay? So I can find the missing term by just adding these together. And this follows the same rule that I basically just told you guys. It should work. Let's see. So you get that. Any questions? Okay. Alright, so sometimes we're going to have to write the explicit formula with what's given to us. So they give us first term, D, and N. That's all the information you need to set up the formula. So I like to set up my formula first, and then once I set it up, I plug in N. Because this is like the standard formula to find any term, and then I use the formula to find the term that I want. So I just prefer doing it that way, and I recommend it because it helps you have a better conceptual understanding of what you're doing versus just like plugging random stuff in. And you should get 44. And then for the last one, what are we missing to find, what term are we trying to find for B? They want to know the 20th term, right? So N equals 20. So now you can just plug into the formula. We get negative 137. Alright, Rodrigo, you want to pass out the homework?
Yeah.
Thanks.